lubricant application, right? So we're starting to get a little bit more practical, right? So in the actual use of lubricants. Now, lubricant application is done in a number of different ways. So, for most bulk oil systems, whether it's a gearbox or hydraulic pack, we are simply topping up with lubricants. So, where lubricant application becomes really important is when we have systems. Let's say, for example, in open gear lubes, we have spray bar systems, or we are regreasing manually, right, with a grease gun. And these are probably the two most common types of grease gun that you'll see out in the field. So there's manual style grease guns, right, which you often see. And then we also have the battery powered or automated grease guns. And something to just caution people on with this. Number one is, how do we know what the correct volume of grease is that we're supposed to be using? It's very difficult to know that. There are a number of different ways that we can calculate. So if you go onto the internet, there will be a SKF calculator, an NSK calculator. There's something called the Trabon lubricant method. There's a whole bunch of different ways that we can calculate the correct amount of grease. But then we have to know, is our technician out there dispensing the correct amount of grease? That's a whole nother question. So we have to define our procedures with a lot of precision, right? The other issue with these manual grease guns is the amount of pressure that they can generate. So it's maybe underappreciated, but a lever style grease gun can generate in some cases up to 15,000 psi, right? So in many ways, we should be treating them as high pressure hydraulic equipment. If you go onto site and you were to talk about something which can pressurize itself to 15,000 psi, we would generally put all sorts of safety controls around it. And yet, with a manual grease gun, we don't. We believe that they are safe, and that's just simply not true. In some ways, what is even more dangerous is these battery-operated ones, because at least with a lever-style grease gun, if you start to encounter some resistance or some back pressure, then you feel it. You feel it in the grease gun. Whereas with these battery-operated systems, you're basically just holding onto a trigger. You never get that physical feedback, and it is very likely that you're going to do damage, if not to a person, right, with the hose blowout, then certainly to a machine. Because, one thing that I always ask is, do you know of a bearing seal that is rated to 10 or 15,000 psi? It's very, very, very rare. And so most likely when we are regreasing, that grease is completely blowing past the seals. Right. So just in terms of manual best practices, again, a lot of this stuff seems really simple, but the basics are just not being done in industry. So it's, are we checking the volumes, right? Both that the grease gun is dispensing, but also that it is the correct volume is defined in the work instructions and has been calculated. Are we doing things like depressurizing the grease gun afterwards? So all of these things are contributing to potential machine failures. And the other thing that we need to ask ourselves is why we are regreasing in the first place. Because in some cases, we are regreasing to optimize the amount of grease or the amount of friction that's in the bearing. In some cases, we are looking to purge contaminants. In some cases, we are using grease as a seal, as in the case of labyrinth seals. Right. So we need to always ask ourselves, why are we regreasing in the first place? Right. And we don't want to just pump, untold volumes of grease, because that could do more damage than good. And remember that there are consequences to overgreasing. We generate more heat, we generate more friction, we generate more wear. And these are all very similar circumstances to what happens when we undergrease. So if that is the case, how do we correctly calculate what amount of grease should go into the bearing, right? This is really important. As engineers, we should be able to define what the answer is. And yet, if you actually go through, and this was done, it was an LGI paper that was published in 2024. If you actually look at the different calculators, right, and you input the same numbers, so the same bearing specifications, same speed, same operating conditions, and you put them next to each other, you actually get vastly different results, which suggests that most of the calculators are actually incorrect, right? And that should put us in a bit of a bind as engineers, because we're always seeking what should be the correct answer. So how do you correctly grease a bearing. Okay, this is when we start to talk about one of those condition monitoring disciplines and the overlap that it has with lubrication, and this is ultrasound. Right. So one thing that people may not be aware of is that you can use ultrasound technologies to actually basically listen to the bearing. Once upon a time, some of the old school technicians will have used, you might have seen them use basically a screwdriver on the side of their head, and then they lean over and they listen to the bearing. This is basically a more sophisticated version of that. And what you can see here, right, is if I can sort of point to it on the screen here, right, here, what we are showing is this is the ideal case. Right? We're not over lubricated, we're not under lubricated. We're in this sort of Goldilocks zone in the middle. And what that is suggesting is that we have correctly calculated the correct amount of grease. However, let's say, for example, it was the work instructions were, well, let's do 4 shots of grease each day, for argument's sake. How do we know what the current state of the bearing is? Because even if that number is correct, if the bearing is already over lubricated, we're just going to keep it in that over lubricated zone. If it's under lubricated, we're going to keep it in that under lubricated zone. That's not ideal, right? What ultrasound does is it gives us feedback, right? It enables us to look at, hey, this is what the sound signature would look like if it was over lubricated. Down here, this is what the sound signature would look like if it was under lubricated. And as we lubricate, we can bring it into the ideal state, right? So again, we're starting to bring in some of these condition monitoring tools. Okay. And so this is what it looks like to have a bearing that is under lubricated and then receives the correct amount of lubricant. And you can see that sound signature collapse. Right. Right. There's actually a sound file that's here, which I don't think I'll play for you. And this is and on the right is what happens if you would continue to pump grease and put it into an over lubricated state, right? So bad